You've learned how to solve triangles, right triangles, using inverse trig functions and other tools. Today you're going to learn how to solve oblique triangles, that is, a triangle that is not a right triangle, using a tool called the law of sines. And here's the law of sines right here. Very straightforward. Simply tells us that the length of side A, the ratio of the length of side A to the sine of angle A is equal to the ratio of the length of side B to the sine of angle B, and the length of side C over the sine of angle C. If you know two of these, if you can create a complete ratio, so for example, if I know the length of side A and I know angle A, and I know either the length or the length of the side or the angle, the measure of the angle, B or C, I can use this law of sines, to solve the entire triangle and find all three sides and all three angles. So let's take a look at an example. Solve the triangle ABC if angle A is equal to 38 degrees, angle C is equal to 83 degrees, and side A has a length of 23. We start these problems every time by drawing a picture of a triangle. So here's a triangle. Doesn't matter that it matches the angles or that it's close. I just need to have something that I can use as reference. I'm going to label my vertices A, B, and C, and I'm going to label the sides A, B, and C. Notice that the sides are opposite their corresponding vertex. Side B is opposite angle B. I'll label the things that I know. So for example, I know that angle A is 38 degrees, and I know that angle C is 83 degrees. I also know that side A has a length of 23. Now, the first thing I can do, since I know two angles, the first and simplest thing that I can do is I can find the other angle. I'd simply take 180 degrees and subtract the two angles that I know, 83 and 38. And I'm going to use my calculator real quick for that. 180 minus 83 minus 38. And I find that angle B has a measure of 59 degrees. So now I know all three angles and I know one of the sides. So I can just set up a pair of equations and solve them to find the length of side B and the length of side C. We'll start with side B. Since I know the length of side A is 23 and angle A is 38 degrees, I know that 23 over sine of A, sine of 38, so we know the actual measure, is equal to B over sine of 59 degrees. Now I'm going to manipulate this equation to isolate for the B. I will, we'll multiply both sides by sine of 59 degrees times sine of 59 degrees times sine of 59 degrees, and that gives me B equals 23 times sine of 59 degrees over sine of 38 degrees. Now I've got the variable isolated. I can take this expression and plug that into my calculator. Now I've set the mode on my calculator to measure angles in degrees, and I'm rounding to the nearest tenth. You will find that with these problems we round everything. We give our answers in decimal, unlike most of the work we do where I ask you to give your answers in fractions. So alpha F1 to create a fraction. Since this is something a little more than just a number, I like to create the fraction template first. 23 times sine of 59 over sine of 38. Press enter, and I have the length of side B, I now know, is equal to 32. All right, we'll review this in class tomorrow, but take this as your introduction. I'll post a short homework assignment. It'll have the answers on it, and you can just do your best to come up with those answers and show your work. Remember to always draw the triangle to start out with, label everything that you know, and then set up equations. For example, for this one, our next equation would be 23 over sine of 38 degrees equals c over sine of 83 degrees, and you would solve that for c. All right, enjoy your online learning day.